Assalamualaikum and good day to Dr. Yamani and to my fellow classmates. My name is Chairiel Azizi bin Khairuddin.
And hi, my name is Aina Azerin.
Today, we will be demonstrating the Lab 1 assignment, which is regarding the memory allocation in operating systems. Memory allocation is an action of assigning the physical or the virtual memory address space to a process, its instructions and data. Two types of memory allocation. The first one is static memory allocation. It is allocated by the compiler. Exact size and type of memory must be known at compile time. The next one is dynamic memory allocation. Memory allocated during runtime. Exact sizes or amounts do not have to be known by the compiler in advance.
The first fit memory allocation scheme is a technique through which the operating system allocates memory to the process based on the memory demands. In this method, the operating system allocates the first memory slot it finds empty to a process. This memory allocation is not considered as a good technique as it allocates huge empty memory spaces even to small processes, which results in massive memory wastage. In the case of the best fit memory allocation scheme, the operating system searches for the empty memory block. When the operating system finds the memory block with minimum wastage of memory, it is allocated to the process. This scheme is considered as the best approach as it results in most optimized memory allocation. However, finding the best fit memory allocation may be time consuming.
Next, we will look at the illustration of both algorithms. In this example, we will use the fixed memory allocation.
This is an illustration of how the first fit algorithm works. As we can see, we have a number of blocks with different sizes of memories. And we have 4 jobs that need to be allocated into the blocks. So, let's see how this algorithm works. First, we take job 1, which is 212K in size. We compare it with the first block size. Since the job doesn't fit because it is larger than the block size, so we move to the next block. The second block size is 500K, which is larger than the job size. Therefore, we allocate this job into second block. Okay, next job. We compare with the first block and it doesn't fit. Since job 1 is already allocated in block 2, we will not check block 2, so we jump to block 3. As we can see, block 3 doesn't fit as well, so we move to block 4. And it doesn't fit as well, so we check for the block 5. And yes, the size of block 5 is bigger than the job size, so we allocate job 2 in block 5. So next is job 3. First, we compare with the first block, and it doesn't fit. So we move to block 3. Yes, it fits, so we allocate job 3 in block 3. Lastly, we take job 4 and compare it with the remaining empty blocks. So we compare it with the first block, but it doesn't fit. So we move to the fourth block, and it doesn't fit as well. Since we don't have any empty blocks left that can fit this job will need to wait until any of other jobs has completed the process. That is how first fit algorithm works. This is an illustration of how the best fit algorithm works. In this algorithm, we will look for the best block that can fit the job. As we can see, we have a number of blocks with different sizes of memories. And we have 4 jobs that need to be allocated into the blocks. So let's see how this algorithm works. First, we take job 1 and compare it with block 1, but it doesn't fit. So we move to the next block, which is 500K in size. Therefore, it can fit the job. This is the best block for now. Then we move to the next block and it doesn't fit. So we move to the fourth block and it fits. Since 300K is less than 500K, block 4 is now the best block. Then we check for the last block. Yes, it fits, but it is not the best block as it is larger than block 4, which is 300K. Therefore, we allocate job 1 in block 4. Next, we move to job 2. We check the first block and it doesn't fit. So, we move to second block. Yes, it fits, and it is our best block for now. Then go to block 3. It doesn't fit, and since block 4 already allocated job 1, we move to block 5. Yes, it fits, but it is not the best block. So, we allocate job 2 in block 2. Next is job 3. We compare it with block 1. It doesn't fit. Then, we move to block 3. Yes, it fits, and it is the best option for now. Then we move to block 5. it fits, but not the best option. So we allocate job 3 in block 3. Lastly, we compare job 4 with the remaining blocks left. We compare it with block 1, but it doesn't fit, so we move to block 5. Yes, it fits. Since it's the only choice, it is our best option, so we allocate job 4 in block 5. That is how the best fit algorithm works. Now, let's look at the analogy between these two algorithms. For the first fit, the first partition fitting the requirements, while for the best fit, smallest partition fitting the requirements. Next, the first fit algorithm will have more wasted space, while for the best fit algorithm, there will be less wasted space. Lastly, first fit algorithm is faster in making allocation, while best fit is a little bit slower.
Now, let's look at the flowchart and programming explanation.
Now I will explain the code explanation and the flowchart. So as you can see here, this is the flowchart for the first fit algorithm. So we will start by initialize the block size and process size array. So in the code here, initialize the process size and the block size. Okay, after that, we will initialize the memory block as free and set no assigned task yet to each block. Okay, here in the first fit method, we will pass the block size, the number of block, the process size, and the number of process or jobs. So here, we initialize all the memory block as free. And in this for loop, we will set each block initially no block were assigned to any job or process. Okay, next, we will traverse each block in a loop to find suitable block size for each task according to first fit algorithm. So look at this part here. We will traverse the process block here. You have a process block to find which is fit to the block size here. So look at the flowchart there. If current process size is smaller than the block size, if yes, it will allocate the task to the block. Else, it will traverse the for loop to find a suitable block. So here, if the block size is bigger than the process size, then we will allocate the job to the block. Okay, for example, the 212 size here, when we traverse the block size 100 is smaller, so it does not fit. Then we will move to 500. So 500 is bigger than 212. So this job will be assigned to this block. Okay, then we will set the block to be occupied and break. So here we set the block size to -1 so that other process cannot be occupied to that same block again. And lastly, we will print the result here. So I will now run this code. So as you can see here, 4 to 6 size cannot be allocated because 212 is already assigned to 500, 417 to 600, 112 to 200, and so 4 to 6 have to wait to be assigned to the next block. Okay, I think that is all for first fit algorithm. And now for the best fit algorithm, it has the same flow process as first fit but has slightly different logic to find the minimum block size that is most suitable to find a job. So we will initialize the block size and process size array, then initialize the memory block as free and set no assigned task yet to each block. Yeah, same like here. And then we will traverse each block in a loop to find suitable block size for each task according to best fit algorithm. So in this line, we set a variable to track for the best fit block. Okay, so if current process size is smaller than the block size, if yes, we will find the minimum block size that is most suitable to the process size. Else, it will traverse the loop again. Okay, now here is the logic to find the minimum block size that is most suitable to the process size. So for example, for 212 size job here, so 500 is bigger than 212, so it will be the current best fit block for 212. Then we will traverse again the block size here. 200 is not fit for 212, but 300 is fit for 212. So at this part, since 500 is bigger than 300, so the best fit block will set to the 300 block here. Okay, after we have found the minimum block, we will allocate the task to the block and reduce the memory left. So here is the logic here. And lastly, we'll print the result and end the process. So here this is for print. Okay, now I will run this code. Okay, this is the result here. So I think that is for basic algorithm. Okay, thank you.